consider preparation and properties of alkenes. So first is preparation of alkenes from alkenes. So we have seen alkenes on pyrolysis in presence of aluminium oxide and temperature around 723 Kelvin approximately. So it gives rise to alkenes. Next, from alkynes, this one, if I add hydrogen in presence of nickel or palladium carbon, I can get alkenes. But suppose we have two substitutions. On hydrogenation, it can give rise to two type of alkenes. One is cis alkene, another one is trans alkene. So which one or which reagent will give rise to cis alkene or trans alkene? Let's see. This one, if I treat it with sodium in presence of liquid ammonia, liquor ammonia, it will give rise to trans alkene. Again, if this one, if I treat it with Lindlar's reagent like hydrogen in presence of palladium, carbon and sulfur, this will give rise to cis alkene. So this is very important, the reagent. So but2ine in presence of sodium and liquor ammonia, it will give trans. So this is the trans product. And in presence of Lindlar's catalase, this will give rise to cis product. So this is how I can get alkenes from alkynes. Now next is alkyl halides. So let's see the alkyl halides part. Now if I treat CH3CH2Cl. So this is ethyl chloride. Now if I treat it with alcoholic KOH, this will give rise to an alkene. Elimination is taking place. Beta elimination. Plus KCl plus water is formed. Okay. Next is alcohol. Now if I take ethanol and treat it with a dehydrating agent. This is dehydrating agent. Concentrated sulfuric acid is an dehydrating agent. Like this one was undergoing beta elimination. This will also undergo beta elimination and it will give rise to an alkene. Now this process is dehydration. So this is dehydration because water is eliminated, and this is dehydrohalogenation. Hydrogen as well as halogen, both are eliminated. That's why it is dehydrohalogenation, and here water is eliminated. So this is dehydration. Now in case of alcohols, what is happening is that when acid is provided, H plus is released, this oxygen is getting protonated and this is forming some protonated molecule. Now this protonated part will leave and this will give rise to a intermediate which is a carbocation. So this is an intermediate which is a carbocation, and to this again, or I can write, this can go and attack this. This can form ethyl hydrogen sulfate, and this will give rise to alcohol on hydrolysis because water is there and sulfuric acid is left behind. Okay, so this is the mechanism. So this is undergoing through carbocation intermediate. Now suppose the alcohol that we take is like this. Okay. Now I am adding concentrated H2SO4. So I am expected to get a product, or if I extend this to this one, butane 1O. Okay. Now if I add concentrated sulfuric acid, the expected product that I am supposed to get is this one, but 1E, 1-butene, but the major product that I am getting is but 2E. I am getting but 2E. So this is the major product. How is this happening? So let's see the intermediate that is formed, and that is the carbocation that is formed. So if I add H plus, this will be protonated and this will be removed. So I will get the carbocation like this. Now the hydrogen that is present here, it will be rearranged or it will shift to the carbocation. So this is 1,2 hydride shift. So this is called 1,2 hydride shift, and this will result in the formation of a 2-degree carbocation. So this will form a 2-degree carbocation, and we know 2-degree carbocation is more stable than 1 degree. So that is the driving force, the stability of this carbocation. Clear? Because this is 1 degree, this is 1 degree, this is 2 degree, and we know 2 degree more stable than 1 degree. So that's why there will be 1,2 hydride shift, where this will lead to the formation of 2-degree alcohol. Sorry, not alcohol, I'm so sorry, an alkene, where the double bond will be formed in between. Clear? So this is how we can get unexpected product from alcohol. Now another example. Another example similar to this. I add alcohol here and CH3 here. Okay. Now I am adding concentrated H2SO4. So this will be protonated. So our expected product is the alkane must be formed here. Right? So because there is no hydrogen here to get eliminated, only beta hydrogen is present on this side. So the expected product, that alkene, will be formed here. But this is not happening. My major product is something else. So the product that is formed is this is the major product. Let's see how this is formed. Let's figure out the carbocation that is formed, and this is the 2-degree carbocation that will be formed. This is a 2-degree carbocation, but you see, if any of these methyl groups shift here, this will give give rise to a 3-degree carbocation. So this methyl is shifted, so there will be formation of a carbocation here. So this is methyl shift. So in this case, this is a methyl shift. So this will give rise to a 3-degree carbocation, which is more stable than this 2-degree carbocation. That's why methyl has shifted to this carbocation. This will now lead to the formation of the alkene. Okay, there is an H. So this H will be eliminated and this will form this product. Clear? So whenever you will find that like adjacent to this alcohol group, there are methyl groups or hydrogen is there which can be shifted to the carbocation that is formed when this alcohol group is leaving after getting protonated. In that case, we will get this unexpected product. Okay. So now let's see the next one. Carboxylic acid. So next is the formation of alkene from carboxylic acid. Now for carboxylic acid, I can get alkenes indirectly. First, if I reduce this to alcohol, then dehydration of alcohol, I can get alkene. Another way is by electrolysis of dicarboxylic acid. So if I take one salt of dicarboxylic acid, because in case of electrolysis we must take an electrolyte, a salt. So this on electrolysis will give rise to this carbon dioxide will be removed. So this bond will be formed. So CH2CH2, carbon dioxide will be removed, 2 carbon dioxide, sodium hydroxide will be formed and hydrogen will be released. So this is how I can get an alkene from dicarboxylic acid. For monocarboxylic acid, we have to do it in 2 steps. Clear? Next, for nitrogen containing compound, again we have to reduce cyanide or amines to cyanide. From there I can get an alkene. If I reduce it to suppose alcohol or alkyl halide, so from there I can get alkene. Next is aldehydes. From aldehyde, the picture is same as that of acid. So if I convert this to alcohol, then to alkene, concentrated sulfuric acid, it will give rise to an alkene. Clear? So this is all about the preparation of alkene. One more thing about the preparation of alkene is that suppose if I take this kind of alkyl halide, this is called vicinal dihalide. To this, if I add zinc or zinc chloride, this will directly form alkene. So this is another way from vicinal dihalide. So this is all about your alkene. Next we will see the properties of alkene. What kind of reactions do alkenes undergo and what are the products or how we are getting these from alkenes. So let's see.